Way back in section 3.3, we learned that the derivative of e to the x is e to the x. If we write that rule down thinking about the chain rule, then the derivative of e to the u is e to the u du dx. In our last video, we learned that the derivative of the natural log of u was 1 over u times du dx. Now, if that was just natural log of x, we just have 1 over x. But that has me thinking. If I can take the derivative of e to the x and the natural log of x, and if I can take the derivative of e to the u and natural log of u, what about my other bases? Is there a derivative for a to the x? Well, there should be. And is there a derivative for the log base a of x? And then I'll want to write those things down in terms of the chain rule as well. Well, in this video, let's see if we can find the derivative of a raised to the x power. So I have y equals a to the x. And I'm thinking right now that a is just any base I want it to be. It doesn't have to be e, but maybe it is e. If it was 1, it's super boring. But I want to come up with a rule that just says, hey, I have a base a, let's find the derivative of y equals a to the x. And my actual goal here is to rewrite this function so that it is e raised to something times x. To rewrite it so that there's a base of e, because I know what to do. I could use this rule, right? Then it would be e to the u, and I can find the derivative. So I just need to think about that. And one neat thing I want to remember is I actually know rules for the logarithm that look like this. And these are actually inverse function properties, right? Because if I compose inverse functions, I get back to x. The log base a of a to the x has to be x. And if I actually think about that, what this is saying is the power I raise a to get a raised to the x power is x. If I rewrite this as an exponential statement, it literally says a to the x is equal to a to the x. Well, yes it is. I like to think about this as a function composition question, but it's really just a property of the logarithm. If I look at this one and kind of start in a silly place that says the log base a of x is equal to the log base a of x, and then just think about one side as a number and the other side as a logarithm, because the log base a of x is a number. If I rewrite this as an exponential, then the base is a, and then this side is the exponent. So a raised to the exponent, a raised to the log base a of x, has to be x. All right, so what does that mean in terms of my natural log? Well, if I let a be e, right, if I look at this and I just say, okay, well, I have e to the log base e is the natural log, then that would have to be equal to x. All right, e to the natural log of x is x. In terms of this, what I want to do is think about rewriting the a. A is equal to e raised to the natural log of a. So here, where that a was, I could rewrite it. A is e to the natural log of a raised to the x power, right? A is equal to that, and a is getting raised to the x power. And when I raise a power to a power, I multiply, telling me that this is really e, the natural log of a times x. Now I have exactly the setup I wanted. I've translated from a raised to the x power to e to a power. I can take the derivative of e raised to a function. So y equals a to the x is equal to e raised to the natural log of a times x, and y prime. All right, the derivative of e to the u is e to the u times the derivative of u. Well, looking in the exponent, the natural log of a is a number times x. That's a linear function, so its derivative is its slope. Y prime is e raised to the natural log of a times the natural log of a. And then finally, I'm going to write that as simple as I can, remembering that e to the natural log of a was a. So all of that to establish that the derivative of a raised to the x power is a to the x times the natural log of a. I like to think about that as a rule for this derivative when a is not e. But this rule actually works when a is e, because this would say the derivative of e to the x is e to the x times the natural log of e, and the natural log of e is 1. So this rule actually works for all of my exponential functions. I guess it's actually kind of boring, but there's a new rule for us. I have the derivative of a raised to the x power. In the next video, we'll take the derivative of the log base a of x.